Okay, hello everyone. Today we will talking about the analysis of Tesla weekly closing prices from 2021 to 2024. The main objective of this analysis was to identify trends and predict missing or future values of the stock prices. Next, next slide, please. Here's our table of content. Next, next. Yeah. To achieve this, we used regression techniques to analyze the overall trends in the data and applied interpolation methods to estimate the values for in-between periods. The significance of this work is that it helps us more accurate predictions and create a clear, seamless data model, giving us a clear understanding of Tesla stock prices behavior over time. Yeah, and we will talk about the algorithm we have used.
For choosing our algorithms, we wanted to implement a method that can capture sudden changes in the data and another method that can get the overall trends of the data. So we choose like the piecewise interpolation and the least square approximation algorithms to reach these targets. For comparing between these two approaches, we can say that interpolation is mainly used for short-term in between prediction, giving low prediction accuracy, and used with sharp transitions between the data. On the contrary, the least square is used for getting the overall trends of the stock prices with the ability to long-term prediction with decreasing the mean square error and yielding better accuracy. And for finding the trends, we started with implementing the linear regression, polynomial regression, and exponential regression. And for the in-between prediction interpolation, we started implementing the piecewise linear interpolation, piecewise quadratic, and the cubic spline interpolation. Next one, please. And starting with the linear regression is what mainly it does is trying to find the best fit line that minimizes the sum of square errors to could represent the data well and be useful for future prediction. As we can see here in the red line, um, is that this model is only capturing the general trend, and according to the analysis and the error values, we reached that the linear model is not sufficient for such a data, for such type of data, especially because the data that we have is fluctuating, keep increasing and decreasing by the time pass. So its accuracy is almost about 11%, and that's led us to implement like the second algorithm. As we can see here, that the mean square error is very high.
So the second algorithm that we implemented was the polynomial regression. As we can see, like the data can seem like a curve, the blue points. So when we implemented the polynomial regression algorithm, we have now like the red line. It actually fits the data much better than the linear one, and it has significantly lower MSE and better MAA and R squared. We used the degree of 6 for this algorithm, and we've got much better results. But actually, the results will be better with the next algorithm.
As the Tesla stock increased very faster, so we also try to use the exponential regression for the stock price prediction. Using the least square method, we obtained the alpha equal to 0.23 and beta equal to 0.0197. I believe this is because the stock growth rate is relatively slow. However, due to the time span, the time index become very large and the predictive stock price increased rapidly as exponential model growth explosive. Regarding the error, we think it is due to the significant volatility in stock price. Exponential functions, on the other hand, are relatively smooth, making them more suitable for long-term stock analysis.
We also apply the quick spline interpolation to predict missing Tesla stock prices. First, we started to transform data into numerical values. Then we used cubic spline methods to smooth the data and estimate missing values. I visualized the original data and interpolated one with a red line, and the model performed really well with an R square value of 92%, indicating that our prediction was uh, close to our actual values. Next.
And for the piecewise interpolation, these two methods are mainly used to connecting the consecutive data points without considering the overall trends of the model, as each interval is treated independently. As we can see here, like in the two graphs we represent here for the linear and the quadratic, they are not that much different. But if we zoom in, we can see like at the data point, like in the linear, it is sharp, like it is a line segment connecting between the two data points. But for the quadratic, it's more of a curve. And the best thing of this is used for like short-term prediction with visualizing the local trends and any sudden change that occur in the stock prices. However, these are simple and intuitive, but doesn't assume a specific model for the data. And it is kind of have a limitation on like there's no smoothing in it, and it is leading like to sharper transition, as I said, and cannot be we cannot depend much on it because it yields like worse in the accuracy than the least square errors. And to summarize our results, we can see here that the linear regression was the worst of them all, like has in the largest mean square error. However, the cubic spline was the mean square error was about like 232, almost 232, which is the better of them all, like reaching at around accuracy of 91%.
To conclude everything, just like Alaa said, the cubic spline interpolation algorithm was the best algorithm used. It outperformed all the other methods with lowest error and highest accuracy. Coming after that was the polynomial regression with like less accuracies than the cubic spline, but better performance than all the other algorithms.
For the future, we believe that it's essential to study more real-time stock data. The current data is based on the past trend. Moreover, we are focusing on the weekly data, which result in the loss of many volatility characteristics in the data. And the second thing is we have only performed regression on the stock price. However, stock price are influenced by multiple factors. Thus, we can consider conducting the multiple regression to account for more influencing factor rather than just focus solely on the previous stock price analysis. And also, we need to consider the different time scale. In the short term, with small time span, stocks price volatility is naturally more pronounced. Conversely, as the time scale expanded, the price change become relatively smoother. Therefore, different models should be adopted to study conduct over different time scale. And here is our reference where we find the Texas stock data sets. And thank you.